Hello. Hello?
Hello?
Yeah.
Hello.
Hey.
Hello.
Very rude of you not to answer when I say hello, but alright.
Hello.
So, I was thinking we should do a little bit of things today. And that is bouncing, right? So when I hit a brick... itchy back! Okay, when I hit a brick... I want that shit to bounce, baby. I want it to bounce. Go back. And how do we do that now? Because right now we can only get if
Just to illustrate, he's pretending to think.
we can only get if we are colliding or not. We cannot get any info about... Hello? We can't get any info on where we collided, or what's specifically quite important. Stop. Don't. No cameras, please. No cameras. We can't get if... we can't get... let me start over. Alright, so we did... so we did... so we can shoot bricks. But to be able to bounce, we need to get something like a normal or something like that to figure out, did we hit it from the underside or the upside or the side or anything like that. So we obviously need some more information out of this. And there's an easy way and a hard way to do this. An easy and a hard way. The hard way is to modify our collision checking so that instead of just getting if we are colliding or not, just a boolean, we somehow get out of it sort of like a normal, you know, some impact normal of the actual surface that we collided with. But that's very hard. So I'm thinking today we'll just do the simple solution. Use the simple... Hello? Is there anyone in there? Just do the simple solution. Right. And what's that gonna entail? What is the simple solution? Well, we'll see. I'm gonna sort of do it gradually. But first I thought, before we start thinking about that, let's update our projectile a little bit. Because before, okay, that doesn't work here. Before, we only hard-coded a movement to the right. But if you want the projectile to be able to bounce and stuff like that and change its direction, we're gonna need to not hard-code this and instead do some sort of velocity calculation or something. So I'm gonna do that. In projectile.h, I'm gonna add a velocity x and velocity y. So that's going to be the velocity which the ball is moving in. So then, instead of hard coding, whoops, instead of hard coding here x plus equals 400, I'm instead going to do x plus equals velocity x and y plus equals velocity y. Okay. Let's see what happens. Okay, so now they don't move at all. Because of course, velocity x and y are gonna be 0 by default, which means we won't move at all. So let's add some values to these. So I'm actually gonna go to player. Whoops. I'm gonna go to player. That's a player 1 to play. So when we hit space and when we're doing the shooty, I'm gonna say, whoops, projectile velocity x equals 200. And then I'll do something like, let's shoot it slightly up or slightly down based on the projectile index. So I'm just gonna say like, if next projectile index mod 2, then projectile velocity y is equal to 200. Otherwise, projectile velocity y is equal to minus 200. So just if next projectile index is even, then we shoot downwards. Otherwise, we shoot upwards. I don't know. Very simple. It's, you know, just to get something in there, just to see if it works or not. Oh, hello, Nelson. The protagonist of FG21, Nelson. Welcome.
Was I unmuted?
Yes? No, you were muted.
Oh, okay, okay.
But I saw your face.
Like I just crashed and I thought it was Teams, but then I realized it wasn't Teams, so my bad.
Oh, yeah, Ruta is running some sort of cyber attack on Discord server, so...
Please don't call me out in public, thank you.
Okay, I'm sorry, she's doing a bake sale. Which is
I thought it was like a charity run, right?
Happens to have quite negative side effects on the internet, but... right. So now we have some velocity being set on our nice little projectiles. So let's see what happens. Let's see what happens, baby! Oh! Look at that. Isn't that cool? Isn't that sweet? Now we can shoot up and down. Amazing. Okay, so let's begin before we do colliding with bricks. Let's begin actually by doing collisions with the top and bottom of the screen, so that we can see them bounce. When they hit the top of the screen, I want them to bounce downwards again. So that will sort of lead into a little bit of how we're going to do it with the brick. And I'm actually going to refactor a little bit first, just to make the code a little bit easier for us to change later, so that we can get this behavior. So just trust me on this, hold my hand, you're safe, and it will make sense in a while, probably, hopefully. I don't know. At least show the top of my head. It's like, I'm not bald. Yeah, I'm at school, by the way, and I hate this. It smells.
Into a glass ball.
People are looking at me. I had a duck thrown at me. An attempt at my life happened. Things I do for you.
I was hitting his hand.
You hit me in my face, I think.
Was it your face? No, it was your hand, and you were like, what the fuck?
David, it's hard to say he's small.
Wait, duck coming.
You tried to hit his hand, but he hit his head.
He hit me right in my fucking open mouth, guys. That's, I'm telling you. An attempt for my life. Okay, anyway, what we're gonna do...
But if you were hungry, that's like food, right?
What? Sorry?
Were you hungry though? Because if you were hungry, that's just food.
Yeah, plastic ducks, very nutritional.
It's good, right?
Yeah, very nutritional. Okay, Tove is getting something from her bag. What is that? Is that drugs? Is that cocaine? Oh, sick.
Some of that to Boden.
Did you bring enough for the whole class?
Good one. Okay, so what I'm gonna do is that I'm gonna make a step function. It's a very common function to have in stuff like character movement or whatever, in physics movement, is to have some sort of function that steps your actor or object forward a certain amount. And later on we're gonna have to handle stuff like collision and stuff in there as well. So we're gonna make a step function. So I'll make it void step, void. And we're gonna do delta x and delta y. So we're gonna say step forward this amount. Okay, so that's what the function is gonna do. So let's implement that. So what we're gonna do in this here little thing is that we're gonna check if the space that we're trying to move is like where we're trying to move to, is that actually a free zone? Is there any collision there we need to worry about? And if not, then we take the step. So I'm actually gonna have it return true. You know what? I messed up. It should return a bool. I said return true, but I meant return a bool. I'm sorry.
So is this kind of like raycasting?
Kind of like raycasting, yes.
Okay.
In Unreal, this is called tracing. No, wait. It's called something, but I don't remember. It's called something. But yes, it's kind of like a ray trace, right? We're trying to be like, okay, this distance forward, do essentially like a ray trace. We're not gonna do a ray trace, but you can think of it kind of like that. And if there is nothing there, move and then return true, which meaning like the step was successful. But if there is anything there, don't move, so stay where we are, and then return fall. It's called a sweep. That's what it's called. I forgot the word, but it's called sweep in Unreal. So check collision. If it's nothing there, move, return true. If there is collision, don't move, return false. So the return value of step is essentially going to be, was the step successful? If it's successful, then the step returns true. If there was nothing in the way and we failed to step, return false.
Emil,
Yes?
people can't join because the Discord room is full.
I knew it! I knew we had to do teams. I'm sorry, I didn't know how popular this was going to be, so we picked Discord from popular demand. But yes, let's move this to Teams. So I'll post the Teams link, so give me just one little sec. This is your fault, Luta. Does anyone have the Teams link still? Tove, do you have the Teams link? Me? Yeah? What do you want? The Teams link? See, she does have it. Holy shit, I can always just ask Tove and she just fixes it. Yeah, exactly. It's like, Tove, can you renovate my house? And she's like, I got a hammer.
I call that.
There it is. Thanks, Tove. Please, I don't have Teams on this fucking computer.
You can use browser, no?
What?
You can use browser.
Okay, maybe that works.
I think that works. I can't say it.
Oh well, okay, download in like a second.
Teams is not installed on the teacher computer, so he's just gonna install that real quick. Oh, look at him! There he is.
Big boss man!
But
Hello?
wait, Nelson, who's smarter?
Huh?
Who's smarter? Or like...
That's stupid hamster, isn't it?
Wait, where's Marta?
Marta.
What?
Ah, Märta.
Oh, it's Okay, my bad.
It's the
Sorry.
one of the retarded Swedish letters.
Why are we talking about my hamster?
It was the first thing I said when we joined, but I guess you
Oh,
didn't have
okay,
your
nice.
headphones.
I
Okay.
mean, I love talking about my hamster, but
Yes.
assuming that nobody else.
Let's
Can we
have a
please
lecture
get
about
the
my
soundtrack for
hamsters.
Eh?
Wait, does Christer have Dr. Hakim as his profile picture on Discord?
Yeah.
The
yeah.
hell?
I drew it for him for GP2, and he changed it.
He was so moved.
It's the book of
I think it was something about he said that he was the Dr. Love or something, so I drew glasses and a stubble on him, and I was like, that's Christer.
that's him.
Yeah,
That's it.
It's
just need a
beautiful
Pepsi.
Clear as
as well.
day.
Just need a Pepsi.
Oh yeah. Okay. Welcome back. Man, I need a smoke so bad, so we might take a break soon, or I might just spontaneously die. Let's finish the step function, and then we'll take a little short, little baby break. Okay, so we want to check collision first. So before we move, we want to check if something's there.
What the fuck is that about?
What? Oh, okay, he's talking about something else. He's having a lot
He's
of fun.
talking about he doesn't know where we are.
Oh.
I knew everybody was going. What the fuck?
Very disruptive to class, but alright. So we're gonna check collision first. Just kidding, by the way. We're gonna make check collision first. So we'll do the collision check we did here. Yeah, let's do it. So I'll just take all of this and put that in the step function. Like that. So, but of course, we don't want to check our current position. I forgot to copy the circle here. Make sure to copy that as well. Yeah, so we're making a circle, but of course we don't want to collision check where we are. We want to collision check where we're going. So we want to we want to make sure that our next step is collision free. So instead of just pumping in XY here, I'm gonna do X plus delta X, Y plus delta Y. I haven't used a normal keyboard in so long. Oh, excuse me.
Bless you.
Thank you. So now we're checking collision with everything in our step here. So if we do intersect something, I'm just gonna remove this just for a little sec. So I'm gonna skip this alive business, and instead I'm not gonna do anything game changing in step, like, you know, destroying bricks or anything like that. I'm just gonna make sure it's like it only moves. That's what it does. Step is only for moving and checking collision, and then we'll handle the brick aliveness a little bit later. So I'm just gonna say if we do intersect one of the bricks, just return false. Say like, okay, there's something here, we can't move, return false.
So, that check Is it like, isn't it a lot of memory to cache and check over every single brick that we have?
Well, it's not a lot of memory. It's actually quite memory cheap, but it is quite computation expensive. Or quite, I mean, it's not that expensive. But, I mean,
But like-
if we're making an engine that had to run on an Xbox, then perhaps we wouldn't make it like this. But it's actually not perhaps as bad as you might think. The only real cost here is that we're having sort of a double for loop where we're looping through all the projectiles and all the projectiles are checking all the bricks. That is actually like the most expensive part, not the fact that we're like making an AABB and a circle for every projectile and brick. That is not the expensive part here. The expensive part is doing the double for loop.
But if we did limit the game to just one projectile, that would be better.
It will be cheaper, yes.
Okay.
Okay. So now we're checking bricks. and then if we didn't hit the brick, then we'll move and return true. So that means we successfully moved because nothing was in the way. So we'll do x plus equals dx, y plus equals dy, and then return true. So we successfully moved the delta we wanted to move. Okay. So now that we have this, in updates, instead of doing this that we had did before, instead I'm just gonna do step velocity x times delta time, velocity y times delta time. Oh my goodness. Times delta time. I have to like look at the keyboard like an old person. We actually we had got one guy at Hazelights. That was my favorite. He was like the dad of Hazelights. He was like this ancient thing. He's been in the industry for like 20 years. But he never learned to like touch type. What he did was that he used only his pointers. And then he would look down at the keyboard and like individually look, like hunt and peck down every key when he was typing. And the most infuriating part was like he didn't look at the screen. So when you saw that he clearly typed a letter wrong, you would have to wait for him to finish the whole sentence. Then he was like, oh, well, and then he like backspace and then try again. So
what a Chad.
You don't have to touch type to be a great coder, apparently. But it was very charming. It's a charming lad. Okay, so let's see if this works. I'm actually gonna remove. It was a stupid choice by me. I'm actually gonna remove this for a little bit, just to make sure, or just to check what happens if we actually do collide now with one of the bricks. So I'm just gonna comment that out a little bit. So we keep our y velocity at 0. Let's see. All right, cool. So now that I shoot the little bit, the ball at the wall, if it goes up to the wall, then it stays there. So it runs up to the wall, but then the step keeps failing, right? It tries to step every frame, but there's a collision there, so it won't step, so it will stay there. And this is exactly how a sweep works in. This is exactly how a sweep works in Unreal. A sweep Well, it won't be this primitive, obviously, it's a little bit better made. But it will try to move up to a point where we hit something and then stop there. And it's very common to use for stuff like character movements. We swept all the time. It's essentially anything that needed collision with a sweep. So it's a very common thing to do in video games.
Sorry, I missed out. What's a sweep?
A sweep is essentially what we're doing now. Like the thing where do a collision check. If there's nothing there, then move what you're trying to move. And if there is something... What? Oh, sorry.
Thanks.
Yeah, no problem. And if there is something there, then move up to the thing that we hit and stop there. In Unreal terms, that they call a sweep. I don't know what it's called in Unity. I don't know if it even exists in Unity, but...
It's the same in Unity.
It's the same? Okay, cool. Yeah, so it's apparently the same in Unity. Well, it's kind of different from a raycast. A raycast is more of a query, where you sort of say like, oh, from this point to that point, is there anything in between and where? And you can sort of get the normal and stuff. But it doesn't do any movement. It's just a query. You're just querying the physics system. While a sweep is more something of try to move and move up to whatever thing you hit. If you hit the wall, move up to that wall and stop. And they give me like some hit information for what you hit. So while a raycast is more just a query, where you're just trying to get information, a sweep is more like do a movement and change stuff.
So would it be a little bit like an on collision enter kind of thing, which we have in Unity?
Kind of.
Or that would be just a
That would be a callback for a movement, but it's semi-relevant, yes. Okay, I've actually never done any physics in Unity. I really should see how much it differs from Unreal. But I've done a lot of physics in Unreal. It's very fun. Cool. Oh, very cool. Let's take 5. So I can go and smoke. So I'm just gonna go out, quickly smoke, and then come back. So let's take a few minutes. Okay, so PRV.
Wait, Emil, wanna get the life hack on that?
Anyone else wanna smoke?
Damn it.
He already took off his headset.
He hasn't left the room yet. You can say it and then we can repeat it to him.
Life hack, just quit smoking.
Haha, I'm not gonna say that. That's
Yeah, Nicholas.
Why you do me like that too? Why you do me like that?
That is dork. It's a dork opinion.
Why
Like,
doesn't you vape?
or you know, the Swedish way, snooze.
Of course. We actually we used to have a snooze factory. No, that's not a factory. Snooze. What do you call a place where they make stuff?
Factory.
It is factory or
This factory.
brewery.
Snooze manufacturer place.
What's the
company.
Swedish?
Well,
What's the
anyway,
Swedish
in Ostrobotnia, where I'm from, we used to have one, but then EU and like other stuff came in, so it's basically it's illegal to sell snus in Finland. So we always go to Haparanda and buy in bulk.
Whoa.
Damn.
But like the snus tradition has been like in the Ostrobotnia for a long time as well.
Yeah. I want to work at the snooze factory. That's
The smell though.
that's the backup plan.
Like your boss would check on you, Daniel, and you would have your mouth full with loose snooze. Like just a powder.
Hey. You gotta
you-
test it.
Yeah, I was just gonna say that would be your comment. That you
should
just
make,
have to test it.
Elden Ring remake, that's Elden Snooze.
Oh, Elden snooze. I like it.
It's pretty hardcore with these old schoolers who use the loose snooze and they just like put it in the mouth, like just open the box and just
Oh, Jesus.
like with the tongue they sort of stick it up.
What?
Yeah.
My older brother
crazy.
does love snus, but he doesn't shuffle it into his mouth.
Yeah, I've seen some guys do that. They just shuffle it in their mouth.
That's
I mean,
like black
people who do
magic.
it, they say it tastes a lot better, or like they do it when it tastes.
Yeah.
But I've heard. Also because you can't just like chain snooze with loose snooze, so you snooze less automatically.
Yeah, but then you always probably like do bigger sort of portions as well, so.
Social media sucks.
Hi everyone.
Yo.
What's this meeting? I just stumbled over it on this.
It's about snooze.
Yeah, but besides snooze, was this a planned thing?
I think it was pretty impromptu, like workshop with Emil.
It was like spontaneous mentoring.
Okay.
I also kinda stumbled into it, and it's my fault that we are teams and not Discord, because they have a 25 people limit in Discord.
But you're all. Is it just Stockholm people and me?
No?
No, we're Boden people here as well.
Okay.
Mm. It's like-
I don't really know who's going where.
Kinda same to an extent. I think I only met like 8 people in the Stockholm class,
There's difference when you say that privately and all that stuff.
and then
There's difference when you say it publicly.
I mean, look at my corner. This is comfy. I'm like stuck here. I haven't moved in like 3 weeks.
You know what? How many fucking Russians say they are for?
Here on Discord you can like hover the people and it says what location they're on.
Oh, damn.
Yeah, and also on the right there's like a sorted list of who's like Stockholm first, and then Skellefteå, then Boden.
Oh, in the Discord.
Yeah.
Yeah.
I realized like a week ago. So, oh, we're like 12 people in my class. I thought we were 50 or something.
But yeah, then it comes to the problem where you see a name and it's connected to an anime character.
Yeah.
Or in my case, a carrot. Yes.
Finland doesn't approve.
It never does. I mean, Finland only approves if you have a Bastu as a profile pic.
Sauna,
Yeah.
you mean?
Sauna.
But the Bastu sounds... I don't know. Wait.
Bastu sounds more lame.
Oh, my roomie that's from Finland just appeared. A wild roomie appeared.
Although it's true, still racist.
Yeah. Her comment is true, but it's still racist.
Oh, we can hear her actually.
Oh, nice.
Oh my god, here's down. I got more. Is copy paste. It's a text macro.
Are you getting along with your assignments?
Have a nice weekend.
I haven't started.
Damn. Speedrun it.
I'm researching an Elden Ring to get ideas.
Doing the like in the game assembly, like that was a level design thing. You just start a game and be like, yeah, like I'm researching this game. It's good. Yeah.
I can't get STL working in a new project.
Oh, what kind of error do you get?
Do you get like linker errors?
I don't know. I get
a bit
like unresolved external symbol. STL,
Yeah,
blah,
yeah.
Blah, blah, blah,
I had
blah,
that
and like
too.
12 of those.
Yeah, it's a bit of a
like-
hassle.
No, no. You know what you have? Did you download Emil's project?
Yeah, but I want to make a new project with STL.
Is it like one of those things you have to do in Visual Studio setting, where you have to, or properties? Just gonna see
Yeah.
with the platform tool set, Visual Studio 2022 is the one you have to have, I think.
I had this issue. I think you can solve it by if the files in Visual Studio, if they show up as like they have like a red minus symbol on them.
Yeah.
Then you have to choose all of those that are like that. Right click and click include.
Yeah, exactly. That's what I
Yeah.
did.
I had this issue just now.
Which files are those?
In the
those-
Solution Explorer.
Yeah.
Or like somewhere, like I have it on left.
Yeah.
It depends.
But if you're creating a new project from scratch, then you'll have to do lots of settings instead of includes and whatever. So it's super hassle.
Yeah, I copied in like the STL folder and stuff. That's the
Yeah, you have to do the includes. I posted a link to a YouTube video. I think I got it to work with that one, but it's a little bit of a hassle to get it running.
I'm also the annoying guy who runs Rider instead of Microsoft crap. 'Cause I vomit when I see it. So, but maybe
Thomas is going?
get what I need anyway.
I think you have to do the include stuff still, but it's just the Rider way instead.
Yeah, hopefully.
Is Rider that much better than Visual Studios? I never used it.
I think it's great.
I think it was good for C#, but now when we changed to C++, I'm back at Visual Studio.
I imagine not even like Rider can't really help save you against C++.
Oh yeah.
It's also the regular Rider don't even work. You have to do this like beta version of Rider.
Can I just say, I think it's been over 5 minutes.
Yeah,
And,
Emil's helping someone here in the classroom right now.
Baya.
Dude, Thomas, your webcam is carrying. It's like you can see everyone.
Yeah.
I don't think you can hear us.
Yeah, like Thomas Vella, you see like, is it Thomas Labine in the background? Then we have David Bourne. Then we have Ruta and then that's Robodoc squad at my desk. That's right beside. That's on the other side of Samuel. Yeah. And then Tove is approaching. The wild Tove is approaching. She's stealing my share.
Emil, way!
And
This
we
looks
have
like a
him,
Renaissance painting.
the man, the myth, the legend, the Emil.
Oh my god, he's so yes. Okay. Hey, don't worry, it's a song.
What a cozy little
Why did I
meeting
come
we're
here?
having in the classroom.
Yeah.
Yeah.
Hello.
Nice.
Hey
Hello.
guys.
Yo.
Avengers disassembled.
Yeah, we had a crisis meeting there. Okay. Wait, why is it focused on one person then?
Yeah, why is it focused on me?
Why is it focused on you?
I don't know.
Someone
how do I,
pinned it.
How do I
I
not?
think someone
Oh,
pinned you.
okay, there we go.
Stop spotlight or open.
It was me.
Alright, so. So, now we have a projectile that stops when it reaches a wall, but of course we want it to bounce. Is David causing a ruckus?
No one
God,
is in.
David, we can hear it.
That's not David.
Who the fuck is
Is
it?
it?
Yeah, can someone...
Emil.
Would you please
It's
stop?
Wait, who is Big Boss Man? What? I'm seeing that now.
Must be some cool guy. Oh.
Okay,
Okay.
I don't know, sounds kinda cringe.
Kinda cringe too. Okay, so yes, so now we've done it so it stops when it reaches a wall, but we want it to bounce. So what is the problem that we have? Let's try to sort of quantify our problems here. Oh dear. I can't get rid of this. There we go. Okay. So if we have a ball, right? It's moving in some velocity. And it hits a cube. We have sort of two cases, right? Either it hits the X side, like the X pointing side. If you're thinking about the normal. In which case the X velocity should be mirrored, right? So the Y velocity will stay the same, and we're just gonna mirror the X part of the velocity. Right, so if it's pointing in towards the wall in the beginning, now it's gonna point outwards. And if we hit the down or up side, so if the Y facing walls, then we're gonna do the opposite, right? If the ball hits that side, we're gonna keep the X momentum as it is, but we're gonna mirror the X component of the velocity. So now instead of going up towards the wall, it goes down. And it's actually kind of nice that we only have these two cases. Like we only have either the X should be mirrored or the Y should be mirrored. And the reason we have that is that all of the bricks are squares. So either there's only two possibilities, right? Either you hit the bottom or top, in which case the Y should be mirrored, or you hit sort of the left or right side, in which case the X should be mirrored. And we can even simplify this a little bit further. Because there is really no way for us to hit, let's just focus on the X facing sides of the square here. There is really no way for us to hit this X facing square by considering the Y component of velocity, right? If we only go upwards, let's say that, if we sort of ignore the X component of the velocity for now, there is no way for us to actually hit this wall or this wall. Because if we're close enough to the square to hit one of those walls, we would instead, you know, hit the corner, which we can interpret right now as just hitting the downside, right? If we pretend that like there's no corner collisions like this, let's do that simplification. There's no way for us to actually hit the sides without hitting the bottom of the top first. And similarly, if we only consider the X component of the velocity, there is no way for us to hit the bottom or the top side without first hitting one of the sides. So if we break out the two components of the X and Y into sort of its X and Y component, we can make some simplifications. We can say if we update only the X velocity, so we only move side to side, then we can assume that we will only hit side parts of every brick. So if that's the case, we don't really need to care about the normal. We don't really need to know like exactly where did we hit the brick, because we can assume if we did hit the brick, we hit one of the sides. And similarly, if we only do the Y component of the velocity and we hit something, we can assume that we hit either the top or the bottom side of the square. Right, so we're gonna like sort of oversimplify things a little bit. Like again, we're ignoring corner collisions here. which might be like a nice next step. But let's start with simple, because I think the simple here will actually be good enough for our to get us something that looks good. So that's actually what we're gonna do, and this is a very common thing to do when you only have stuff that is axis aligned. So, you know, in, for example, a 2D game like Mario, like if you look at Mario 1, there's only like discrete tiles, right? There's only like, you know, a tile set of 32 by 32 sprites. And there we can make that assumption that if we update Mario in only the X direction and we hit something, we can assume we hit either the side of a tile, you know, one of the side tiles. And if we update Mario's Y position, then if we hit something, we can assume we hit either the bottom or the top of something. So let's do that.
I was just thinking, can't you just multiply the direction by -1 when you hit either top or bottom?
Ooh, that's an excellent observation. Let's keep that in mind. Let's save that in the back of our head a little bit, but that's a very good observation. Let's split this up first. So in our step, and this is exactly why I made a step function, because now we can call the step function multiple times per frame. So instead of just stepping once with both the X and Y, instead I am gonna step with let's do the X first. So I'm gonna step twice. I'm gonna step once with only the X velocity and then 0 for Y. And then I'm gonna step again with only the Y and 0 for X. So I'm splitting up the steppingness so that we step twice, one in X and one in Y. And we still should end up in the same place, because I mean all I've done is just split up a vector into its X and Y components essentially, right? Instead of stepping, you know, the full velocity like this, instead we step first in the X direction and then in the Y direction. There we go, my wonky arrows there. But we still should end up in exactly the same place. Man, Nelson's mind is just completely blown. He's totally doing the Always Sunny board. Right. So, let's see what happens now. So I'm actually gonna add back the Y velocity here. I'm not gonna make it as extreme, but I am gonna add back the Y velocity a little bit. So I'm gonna do, instead of 200, let's do 20, just so it goes a little bit upwards. And let's see what happens. So again, I haven't done any bouncing. I've only done, the only thing I've changed is to split up the X and Y components of the velocity and stepping them separately. So let's see what happens now. And now we can actually see something very interesting. That it's actually sliding against the wall and then sort of finding its way through, which is quite nice. So instead of just stopping, like if I change this back to what it was, but with the Y velocity, oh, whoops. I add a bunch of balls here. you can see that they go up to the wall, though even though they have Y velocity, like they should be able to get through, they sort of get stuck. And that's because it's just trying to move once, and if there's nothing, if there is something there, it just stops. It doesn't move at all. It doesn't even try. So that's why even though these guys have some Y velocity up and down, they get stuck on walls. But if the only thing we do is just split up the X and Y. Suddenly they will sort of find their way through. And you can see why this would be very useful in games, right? If I'm playing some top-down game, if I'm playing, random top-down game, if I'm playing Zelda, yeah, sure. And I'm sort of running against the wall, right? If I'm running diagonally against the wall, I don't want to just like get stuck at the wall even though I'm running diagonally. I want to be able to still sort of get through the wall, like sort of inch my way along until I'm past the wall and then keep going. So this is a very simple trick you can do in 2D games like this, where all the walls are always sort of in this axis aligned way. It's a very simple trick you can do to get very nice movement very easily, just by splitting up the X and Y move. It's very cool. Of course, when you start coming to stuff like diagonal walls, ramps, anything like that, suddenly this won't work anymore. You can still get stuck when you shouldn't. So that's why as soon as you start having stuff that's not axis aligned, you start having to do a little bit more sophisticated algorithms to actually do this kind of behavior. But that's why when I make 2D games, I usually keep all the walls axis aligned, just to make the movement code super easy. So then I don't have to do any sort of advanced math to figure out the normal and like do constrained movement vectors and sweepings and whatnot to get what I need. I can just do this simple trick. One simple trick, guys, to do nice movement. There's my clickbait title for this video. Literally one simple trick. Subscribe to my Patreon. We're trying to get to 3 Patreons this month, so we'll be very happy. Right, so.
Can you show the step again?
Yep. I was so sure you were gonna look at me and say like, that was very funny, Emil, but then you was like, scroll down, asshole. Okay. But of course, we wanted this to bounce. But Nelson is just still completely flabbergasted. You want help, Nelson?
Oh, I'm actually reading something else. Forgot I had my camera on.
Oh, okay.
My bad.
No problem. Just turns out like no one's listening to me. Everyone's just doing their own thing and just show up.
I'm listening.
Yeah, okay, good.
Yeah, don't worry, I'm listening.
Okay, thank you.
But could you show the step function again? Or like, oh, never mind, it's there. Oh. Yeah.
You became insecure there for a second.
Yes, a very insecure teacher. I always need constant.
Yeah, you're doing fine.
Thank you. Thanks, guys. If you want to comment on my looks as well, that would be nice. I'm looking good today, I hope.
Yeah.
Kinda, I guess.
Thank you, guys. Very insecure man here. Yeah. But so, okay, cool. But of course, what we're gonna do is not that, like when we're playing Breakout, right? You don't want the ball to just kind of slide along the walls, right? You want the ball to actually bounce. Another nice trick we can do here, since we're not handling any sort of weird collisions where the normals have to be taken into account to like what our current velocity is, and we have to like do a mirror function or something like that, or a reflection function rather. Since we're kind of constrained down to, we can only do collisions either directly into the X or directly into the Y. Like we always know the normals are gonna be those two things. We can actually do a quite nice trick, which someone already figured out, which I'm very proud of. That was a good job. If we're hitting a wall, let's say from the side, so we're coming in here, and the velocity looks something like this. You know, all we need to do to reflect this vector along sort of this x-plane here is to just reverse the x-axis. All we have to do is just flip the x-axis, so it's pointing this way instead. Or in other words, all we do is just do like the x velocity times -1. Thank you, David. I love you too. You're my babies. Haha. Don't forget. Was that weird? I don't think so. It was very normal thing to say.
That's actually really normal, because in fact we in Boden have like a family composed of Niklas, who is my dad, Charlotte, who's currently not here today, but she's my mother, and I feel very adopted in here, so you guys should have the same thing in Stockholm.
Nelson, I was meant to be your secret.
What do you mean?
The family-run Boden.
I always
I
knew
mean,
you were
like-
the weak link.
Like in Stockholm, we also have something similar with Daniel being the younger brother of everyone. Yeah,
It's
that's
everyone's younger brother. I like that.
everyone's younger brother.
It's a good, it's a good thing. All right, so we can simply just flip the x-axis of the velocity, and we'll get the bounce for free. And same thing for when we're hitting the down or the upside, we can simply just flip the y-axis of the velocity, and it will just work fine. And we don't even need to care did we hit the left or the right side. We don't even need to care, because if we hit the right side, then we necessarily have to go to the left. Like the only way for the only way for us to hit the right side of a wall is if we're going to the left. So if we flip the x velocity when we're going to the left, then we'll be going to the right. And same thing, if we hit the left wall, we necessarily have to be going to the right. So if we flip the x velocity there, we'll be going to the left. Oops. So let's just do it. So, if our step failed, that means we hit something. And in this case, we're checking the x velocity, right? So then I'm just gonna do x velocity, or velocity x, is equal to minus velocity x. You could also do times equals -1, if you want to flip it that way. I think this is quite clear. It's just like we want to just flip it. And same thing if we fail the step in the y direction, then we're just going to do the same thing for the y. You're just going to flip it. Shoot.
Couldn't like the second if statement on row 15 be an else instead? Or why are we making that another if statement?
Oh, whoops. Well, because...
oh, okay.
Well, it should be like that, first of
Yeah,
all.
okay.
But yeah, this doesn't really change the question. Well, because if we hit something on the X when we try to move on the X direction, we still want to move in the Y direction, right? We still want to move upwards, for example, if we're moving upwards. But if we do an else there, that means if we hit something in the X direction, will you skip the Y move? Which, you know, maybe it makes sense, I don't know. But I don't really see the reason. Okay. I think it makes sense to always keep moving. But I can see where you're coming from, and that kind of can trip you up a little bit. Speaking of flips, yeah, I'll do that at the end of the lesson. So let's see what happens now then, if I play. If I play Dota. So now, oh my god!
Whoa!
They're bouncing. See if I can hit the...
I was muted, but I said whoa as well.
Oh, thank you. I'm glad you clarified that. And we can see, even if I hit the top here, you see I bounced against the bottom of this rectangle here. Boop. And then I get down. So the Y flips as well. Cool. Very nice. So let's do the same for the sides of the screen then, so they actually stay here. So to do that, in step, I'm just gonna first check collisions with brick, and then I'm gonna do check collisions with game borders. Emil, why you smoke instead of vape? I actually vape. I just said smoke because I wanted to sound cool. But I'm not cool, actually. Okay, thank you, Daniel. I'm glad you think I'm cool. So, to check collisions with game borders, I'm simply just gonna check, is the X less than 0? Which means like, okay, we have left the left side of the screen. Or is X greater than the width of the screen? In which case we ran off to the right side of the screen. So I'm just gonna start there. So we're gonna do if X is less than 0, or X plus delta X, of course, because we want to check the next position. Or X plus delta X is more or equal to, let's see, how big did I make the screen? 800. Okay, so I'm just gonna hard code this. Why not? 800. And then we'll do the same for the Y. So we'll do Y plus delta Y is less than 0, or Y plus delta Y is more or equal to 600 in this case. So if we either left the left side, right side, top side, or bottom side of the screen, then we're gonna return true. Then it's like, uh-oh, we hit something. We hit the sides of the screen. Pretty simple. Pretty simple, pretty simple. Shit. Man, I can't stop fingering this stuck. Yeah, that didn't sound right, did it?
Yeah, maybe.
No, not return true, we're returning false. We didn't move. I'm sorry. What, did I kill the mood in here now? He's wording a word. Phrasing.
What mood?
What? Oh wow, okay, damn. Spitting fire. Yeah, so if we hit the sides of the wall, then we turn false. And it's like, oh, we couldn't move, because if we move, then we move into a wall. So let's see what happens now. hopefully all the bouncing should already be incorporated. So let's see. Ta-da! And now they're bouncing against everything.
I know this is a low bar, but this is the coolest shit I've done in C++ so far.
Yeah, bro, I'm the cool teacher. When you come to my place, we do cool things. This is like Liero, right? We could do Liero in this. Like the bouncy mines. Shout out to all my Liero friends.
Hold on.
Hell yeah.
Did you just say we can do Liero? As in, we will do it? Assignment
I feel like I made a promise now that I can't keep, so yes. Okay,
GP3 everyone.
Let's make the Y velocity a little bit more extreme, so that we can actually have them bounce a little nicer. So I'm gonna go in here and just change this to 200 and minus 200 again. Just like common for it to go directly diagonal and break out. So let's see, let's shoot some balls. And there we go. And you can even see that if it hits one of these little gaps, it will actually bounce through, which is quite cool there. You see that? So it bounced through the little corner there. Very nice. So that's bouncing. So we have some basic physics going. Now, if you want it to be cool, and I like cool stuff, I can actually tell you how we would do. I mean, this isn't a physics course, it's just that I love to do this. A very common thing when we're doing bouncing like this is that every time it bounces against something, it loses a little bit of energy. So, which is a very common thing we did in It Takes Two and everything. So, like, whenever something hits something, it would always like lose a little bit of energy and with friction and stuff. So, I'm just gonna show you because I just think it's so cool and it's so easy. When we're doing the flip here, I'm just gonna multiply that by some factor. Whoops. I changed the language. I guess Swedish. I'm just gonna multiply that by some factor. So let's say 0.8. What that will do is that every time it bounces against something, it will lose 20% of its velocity through friction. And this is called something called restitution for some reason. I don't know why it's called restitution. It's such a bad name. I usually call it bounciness, like how bouncy is something. So the less restitution, the less bouncy it is. So if you have something like iron or metal and you drop that on something, it wouldn't bounce at all. But if you have like a bouncy ball and you throw it down, it will keep almost all of its energy in the bounce. So let's see what happens. Of course, this is not part of breakout. They're not supposed to lose velocity when they bounce. But yeah, so now you can see like as they bounce against things, they sort of lose a little bit of their energy. So it starts to slow down. It's quite nice. All right.
I actually want to ask, in the footage that we had for Arkanoid, the ball bounces apparently make it go faster. Actually,
oh.
Like I don't know if it's exact, but every now and then, if you look at the ball, it's like moving at a certain speed. And if you tap forward in the video, the ball eventually just like goes faster, and then it goes faster, and it goes faster. And
yes, that is actually a feature in Arkanoid. So let's do that then. We can very easily do that by just instead of making a less than making this value less than 1, we just make it slightly more than 1.
No, make it 2.
Make it 2. All right. Well, you asked for it.
Yeah, it's gonna bounce really.
It's gonna be so
fast
fucking
and
wonky.
It's gonna explode.
Awesome.
I always have at least one designer. When I add this bounciness thing to physics objects in at Hazelight, there was always at least one designer who put it above 1, and they got surprised that it just completely exploded. But yeah, let's see what happens. So it's just balls and oh god!
Oh yeah!
And there they go, and then eventually they just get stuck. Yeah, so that's very dangerous to do that.
By the way, why do they after like they hit some certain threshold? Why do they get stuck? Is it like the computer that can't process it or something like that?
It's actually because if you guys have seen like the Super Mario 64 videos of the guy doing like 0 things, the problem right now is that these guys are moving so fast. Let's make this bigger. Like, so here's the map, right? These balls are moving so fast, their velocity is just always gonna be off screen. So like they will keep bouncing forever. So like here it will hit like the top side, so it's gonna flip its X and then gain a little bit more speed. And then it's gonna hit the right side and gain a little bit more speed. And then it's gonna hit the left side and gain a little bit more speed. So it's just gonna bounce all the time. But since we're not moving when it hits something, remember in the step function, we told it like if you hit something, don't move. It's just every frame hitting stuff and getting bigger and bigger speed, but it's just never moving because it never comes a frame where it tries to move and does not hit something.
Oh, so that's why it looks like it's standing still.
Yes, so that's why it looks like it's standing still.
No.
And at some point,
no, it doesn't just look like it actually is standing still, right? Like the position variable is not being changed.
Yes, the position variable is not being changed. But if we looked at something like the velocity, then we will see that's probably gonna hit. Yeah, it's probably gonna hit inf at some point, and then you stop working altogether. But yeah, so that's why it stands still. So yeah, be careful with that number. Have it something very small, so it doesn't explode. I'll do like 1.1, probably a good value.
I think that any number that you put above 1, it will eventually explode. The question is how fast though.
Yeah, that's why I think you might not even want to do a multiply there for that. You might want to do something like a plus. So you add...
No, just multiply by 5, it's fine.
Yeah, it's multiply by 5, yeah, it works.
Yeah, but you can probably put like a variable that holds the speed of the ball, and then if it's below that speed, then you can just multiply it.
Yeah, so here we can see that this ball here, its Y component is now so big that it just stays in one place in the x-axis, and then it's just gonna keep bouncing. It goes through the wall there at some point. Just tunnels through. So yeah, if you do the bouncing, you might want to do, instead of doing a multiply, because that's exponential, right? Because it's always 10%, and it's 10% of that bigger number, and then it's 10% of that bigger number, and then 10% of that bigger number. So it just keeps growing exponentially. So instead, you might want to do some sort of like plus the sine of velocity x times 10. Is sine not a thing? See the math. Doesn't have sine. Okay, we'll make.
How
sine.
can it not have sine? It's like really basic thing.
I think you need abs actually, not sine.
No, we want sine, because what we want to do is that we want to add 10. But if the case is that the velocity is negative, if we add
absolutely.
10, it's actually gonna go slower.
Yeah.
Then we want to do minus 10. So then that's why we do like the sine of velocity, and then yeah. So we do, if a is bigger than 0, then return 1, otherwise return minus 1. We're not gonna handle the sine of 0. We're just not gonna handle that. There we go. Plus sine of velocity y times 10. Right, so now instead of growing by 10%, it's gonna grow by 10 speed. So that way it's not exponential, it's a linear grow. So that means it probably won't explode anytime soon. And there we go. Did I fuck it up? It looks like that thing's going slower.
It's lagging too much on the team stream, so we can tell it.
Did I fuck up? I don't know. You'll have to debug this yourself. I'm just gonna bail. It's like, it works for me, guys. Works on my machine.
Do you want the sign of the new of the flipped value, maybe?
Oh yes, you're right. Exactly. Good catch. All right. So that's bouncing. Good to have. Let's end the things there. So let's take some questions. I'll stick around in the classroom a little bit longer probably, to see if people want help in person or not. Otherwise, thanks guys for this impromptu mentoring lesson. I was very happy that you guys from Boden and Skellefteå wanted to show up. Actually, that's very nice. Very nice of you to show up.
Thank you, Emil.
Yeah, thanks.
Yeah, no problem.
Thank you.
Thank you for saving the C++ course.
Yeah, no problem.
For real though.
Yeah. Saving. Yeah, no problem. Alright, any questions? Can you paste with what you have right now? Yes, I will put everything up, the code that we have. Alright, otherwise, cool. Thanks guys. I'll see you guys. Apparently I'm gonna have Christer ask me right now, essentially, if I wanted to have a little lesson on templates on Monday.
And you said yes, right?
Yes, I said yes. So on Monday 9 to 12, we'll have a little lesson on templates.
Oh god.
So
You better not be late.
Why?
no promises on being late or not late, but I will try. I can only promise I'll try. The day I have to show up on time is the day I quit, as my old teacher would say. So that's what I will say. Alright guys, thanks so much for coming, and I'll see you guys on Monday. Okay, bye bye. Sorry, did someone ask anything? I can't hear, someone's
Will you
talking
be here
to the
in
left
person on Monday?
What?
Will you be here in person on Monday?
I can't promise anything. Since I get up at 8:30, I
That's
think
because
I
you're
will
going to be in person in Boden, right?
Yeah, I'll come up to Boden actually.
Yeah,
That sounds nice. How long does it take? Like 5 hours? Probably?
No idea.
5? It's 1,000 kilometers from Stockholm.
1,000 kilometers?
Yeah,
that's like
it's gonna take like 8 hours at least.
That's what they say. Like that's how they measure like the distance between planets. They're like, yeah, this is like 5 Stockholm to Bodens between like Uranus and Jupiter or something.
Can confirm. Yes.
Yes. All right,
I think
guys.
it's like 12 hours on the train.
Oh God, Jesus Christ. All right, guys. Anyway, bye. So have a nice weekend. See you Monday. Bye. Love you. Love you. Okay. Bye. Woo.
Careful with my shit.
Sorry. I'm sorry.